So in this video, we're going to continue topic 4.1, and we're going to look at interpreting the derivative in context. We're going to kind of look at some specifics on that and try examples 3 and 4. So to interpret the derivative in context, be sure to include the following. And these are kind of two different ways to think about it. One of them is a nice little acronym that a lot of people use. So context, don't just name the function. So including what the function is modeling with words. So context is super important. Units, include the units for both the answer and the x variable, which is often time. Instantaneous time, it must be clear at t equals something. And then rate, include the word rate in your sentence, okay? So kind of a shortcut acronym to make sure you get all of that is NUT, okay? And NUT stands for, make sure you have a noun / a number. Basically, it's the subject of the problem and the numerical value. U is for units. Make sure you label with appropriate units. And T is for time. So include the time at which the derivative's change was computed. All right, so let's take a look at example 3. So we're going to go back to example 1, and we're going to interpret the meaning of that in context. And they kind of give you a nice little sentence frame here. So the blank f of t in context. So if I went back and read what example 1 said, it says that the height of the sunflower in inches is measured over the course of 7 weeks. So the function in words would be the height of the sunflower. Is, and then we want to know if it's increasing or decreasing. So I'm going to look at the number, and the number we got was positive. So we would know that that would be increasing. So it's increasing at a rate, and we said the word rate in there because we know we took a derivative of, and this is f prime of c with units. So what was our value? If I went back and looked at my value, it's 9 inches per week. So 9 inches per week at time t. So we got to figure out what time we were at. They specifically wanted us to do this at time t equals 2, and that was in weeks. So at time t equals 2 weeks. All right, so now let's try it from the very beginning and get the sentence in to do the interpretation. So a factory produces delicious cans of corn for the typical corn enthusiast. One particular machine is notorious for packaging cans of corn at impressive speeds. The amount of cans this machine has packaged after t seconds is modeled by the differentiable function c of t. Approximate c prime of 1 using correct units. Interpret the meaning of this value in the context of the problem. So again, I want to figure out where 1 would be between. So I'm going to use between 0 and 2. I'm going to do the calculation. So c prime of 1 equals, and I know the derivative is the rate is just the slope. So I'm going to do c of 52, sorry, not c of 52, c of 2 minus c of 0, and then I'm going to subtract 2 minus 0. So c of 2 is 52, and c of 0's y value is 16, all over 2. And then 52 minus 16 is 36 over 2, which is equal to 18. And then I need to make sure, now I'm going to put it back in the context of the problem. So I'm going to say that c prime of 1 means the amount of cans of corn, right? Of cans packaged. I could say cans of corn packaged. I'm just going to say cans packaged. That's my noun. Packaged is increasing because I got a positive number. If it was decreasing, I would have gotten a negative number. It's increasing, and I were use the words at a rate of, and then I'm going to tell them the rate, which is 18, and now I have to do my units, right? It would be cans per second. Cans per second. At, and we want to talk about the time, t equals 1 seconds.